Next speaker is Joost Cassee with developing a developer-friendly Hypermedia API with django-rest-framework and Behave. Thanks.
Thank you. Hi everyone, my name is Joost Cassee and I'm going to talk about Hypermedia, one of my two most favorite subjects. But first, a bit about myself. I'm a developer, co-founder of Painless Software. I'm also responsible for the Go About trip planner, or the technical side of that at least. And I do my own freelancing projects. On the right-hand side, I've listed a couple of open source projects that I initiated and worked on. So before we start, you can look at the sheets. Usually in this room like this, everyone has their laptop in front of them. But you can follow along with the first URL. All the code is on GitHub. That's the second URL. And I will be using a browser for HAL APIs, one of which I put up where you can browse through the API that I'm going to show you yourself. So what I'm going to talk to you about today is how to design a Hypermedia API. And I will talk a bit of what I think are the most important elements of Hypermedia API. I will tell you how I've implemented such an API in django-rest-framework. How to use Behave to both document and test the API. And then, if we have time, I want to tell you something or show you how API evolution is helped by using Hypermedia API. You no longer have to use API versioning anymore. So, but I want to start at the basis, and there's of course been a lot of introductions to Hypermedia, and I'm going to do another one. But this one is very personal. I'm kind of going to try to highlight what I think are the most important elements of Hypermedia API, and then tell you why you should care. So, to start with, there's a resource. A resource is something with basically a URI. And a resource has a representation. A representation is a string of bytes, basically. In this case, it very much looks like JSON. That's what this defines. This is application JSON, which means this is a piece of JSON text. That's the JSON representation of the resource. Now, this resource also has a type. So what the representation has a syntax, the media type, but it also has a semantic type. It's a ship, which is independent of whether you have an XML representation or a JSON representation. This resource represents a ship, and you define that using a profile. Now, together, these three elements are the most important things to say about a resource. So it's a resource, it's identified by a URI, it has a certain profile, it has a type, and is represented in a certain form, in this case JSON, by this string that you see here. And so this is the basic thing about REST, representational state, and then we can transfer this state, and then we have the full REST acronym. Now, I believe that REST is CRUD. It's basically state transfer, transferring states. It's not really CRUD. The C is not really a C. It's more like processing. So you can read resources, you can update, write resources, you can delete them, and you can do something that is processing. And processing is pretty much defined by the application. It's the post method. But instead of, so when you say to people REST is CRUD, they immediately begin to get annoyed because they say no, it's not. Well, I think there's a misunderstanding between whether you do CRUD on your database models, so directly from an API to the database, or you do CRUD, you try to model the business logic in terms of transferring state. And that's a very important distinction, I think, to make. So this is REST, basically. Now we're going to add the Hypermedia element. And we do that by adding references, Hypermedia references. Basically just a URI, but if you use it not to identify a resource, but to point to another resource, you call that an href. You know that from HTML, of course. That entity over there. Now you can just use an href in a representation. So in this case, we can model the owner of a ship, for example, just adding a property to the representation, pointing to a ship. GitHub does the same thing in its APIs. And it's already a pretty nice way of referring to other resources. You see it already becoming a bit of a web instead of singular resources that you individually get. Interesting is that if you would define a profile for a ship, you would add some documentation about if you find an owner href in the ship, that means that there you can find the owner of the ship. So this is a part of linking resources together defined by the types of the resources. There's another way of linking resources together, and that's by using hyperlinks. And hyperlinks are more like metadata. So they can apply to any resource. You can say about any resource, it has an owner. It basically works like this. You have a specific resource with a relation to another resource. So kind of like, looks like RDF. Some of you might have worked with RDF. And this is the basis of what is called Hypermedia. So you have the plain representations, you have the ships, and you have the, I don't know, invoices, any data that you're using in your API, and you can add these links as metadata to the resources to make them refer to each other. Now you need a way of adding the links to the resource, and you need a Hypermedia media format for that. And one of the most well-known is called HAL. HAL is the Hypermedia application language. It's a very simple model. You take JSON, and it has 3 parts. So the left upper side part is just the JSON properties, and then you add the blue part, which is the links I just showed, and then you add embedded resources. This whole thing together, you can, it becomes one representation that you can get and you can post. Let me show you how that works. So I'm going to show you the HAL representation of the same ship that we just saw. So this is the properties, just the name, the data of the ship, and then the laptop goes into mode. So then we add links. And we add links in HAL just by adding a property with a reserved name, _links. And you see here that it adds 3 links to this. The first is the self link, which is just the identifier of the resource itself, so you know where to find it. The second is the profile, we already talked about. That means that the client gets a resource and then sees the profile and knows, okay, now I know what this is a ship. And so it can use special processing for when it processes ships. And then it adds the third relation, which is a real relation to another resource, which is the owner in this case. You see that the first 2 are just plain words, and the last one is a URI, and that's because just like, for example, in XML, we use URIs to identify relations and profiles, and the plain words, they are reserved keywords by the internet naming registry. So they are defined in RFCs. And now a client who understands Hypermedia, understands the profile, and understands these links can already determine a great deal about the ship. But now, if we look at the ship and the server thinks, okay, well, when a client shows a ship, they almost always show the owner. It can choose to embed, for example, in this case, the owner resource into the response for the ship. So that when the client wants to show the owner too, it doesn't have to make another HTTP request to get the owner, and it has all this information one request, which is especially interesting for example, mobile applications. And you see that it also has, it's embedded with its relation, it's this owner relation, and then what you see there is the whole representation of the company that owns it. So this thing also has a self URI, and if you would type in the self URI and get that, you would get the same thing. This snippet that is embedded is really the same thing that you would get if you get this self URI that's here. So this is used mostly as a caching mechanism. Now, I just told you a bit about how to link, right? About embedding a link in a property as a property, or embedding or using real hyperlinks to link resources together. And there's an important distinction between the two. So if you embed a URI in a property, it becomes part of the type of the resource. It's defined by the profile. And if you allow clients to put the resource, that means that the clients can change the URI. So they can change the relation to the other resource. And if you are a good API citizen, then you will never introduce backwards incompatibility. And that means that as a server, you cannot remove the possibility of linking anymore without introducing backwards incompatibility, because you have promised clients that they will get this property. Now on the right-hand side, you see a hyperlink. Now hyperlinks are part of the API wiring. They're not really part of the state itself, which is the data itself. It's not defined by the profile. It's not defined by the ship. The fact that it has an owner is not defined by the type of the ship. It's added. It's its own thing. It's not mutable by the client usually. Usually you don't allow clients to change these kinds of links. And there's a mechanism for introducing backwards compatibility here, because you are not promising the existence of any links. You are free to remove them as a server. It's usually not appreciated by clients, but sometimes semantics change. I have an example of that. And this is the way you can evolve your API without doing whole API versioning. So using linking, we have REST, we have now linking, and now we can go full scale with this beautiful term, which I've never been able to pronounce. Hypertext as the engine of application state, or in other words, REST as REST was meant to be, if you believe some of the more vocal proponents of Hypermedia. In effect, it means that you traverse an API using the relations without seeing the API as a collection of specific URL endpoints. So it works much more like the web. So this is the example that I'm going to use today. It's a ship registry. And a client will come in through one known URL. We'll get something called, the ship registry. It's often called a root resource, the first resource you're getting from an API. And this resource defines a link, a search link where you can get collections of ships. These ships will have relations to individual ships. These ships will have relations to companies, and these companies will have relations to other collection of ships, namely the ships that they own at that moment. And so the idea is that the client will not jump in and just get one ship. There's no documentation about you will get a ship by entering, going to this URL and typing something. It's all defined using these relations. And I'm going to show you in concrete how that works later. But the elements of a REST API are a root URI, a set of profiles, and a set of relations. Those are the three things that a Hypermedia client needs to understand to use API. And so basically you're not describing an API, you're describing more like a protocol. So if you write a Hypermedia client, you will add information about these profiles, relations, and one URL. These clients will treat the URLs as opaque. They will not try to understand, structure, change URLs to get other resources. They will only follow the links. They will assume backwards compatibility of the state itself, so only the data properties, but they will be robust in the treatment of links. So they will not crash and burn when a link that they expect to find isn't there anymore. Now on the other hand, a Hypermedia server needs to decide what links to give to the client. And that's decided based on business logic, user roles, and service availability. And that means, for example, that a logged-in user can get extra links from a server. For example, for editing a profile or looking at stuff that an anonymous user cannot look at. And it will decide on what resource to embed, again based on business logic, based on what it guesses the client will do with the information, and based on client-server negotiation. So there are ways to say as a client, I want to have a ship and I want to have the company embedded, or I'm not interested in a company, just give me the plain ship, I don't need the embedding. Now, if you do this, this is a departure from how most REST APIs work at the moment. Most REST APIs, most documentations of REST APIs describe URL endpoints. And so this means that people who write clients need to be thinking in a slightly different way. They need to make their clients a bit more robust in the sense that they need to be able to handle the absence of the links. And it's often also the case that when you follow a link, it's not really clear what kind of thing you will get in response. Sometimes, for example, APIs will say, well, if an error occurs and we can't really show you anything programmatically, we will just give you HTML and we expect you to render the HTML to the user. So profiles are a way of giving the server control over what the client will show. And it means that you need to think about how the API is wired together, how to reach certain resources, making sure that the client doesn't need to do too many requests. But they give you reuse of information, of types, of profiles and relations. So like I said, you're really describing a protocol. And there are many Hypermedia and HAL APIs already available. If they use relations, you can reuse the same relations if you need them. And then a client who understands this relation doesn't have to be reprogrammed for that particular part. They allow navigation across APIs because, as I will show you, the endpoints aren't fixed. So that means that an API that is a ship registry can seamlessly point to another API that is a company registry, something like that. So you don't really need everything in-house. You can go into the web, basically, of these Hypermedia APIs. And, as I said, they define an API evolvement strategy. So, to quickly show you how this works, these are two URIs. One of them is a person, one of them is a contact. Say the first one is an employee, the other one is a contact. They're both persons. And so you can reuse the same profile because they have a name and maybe an address and stuff like that. And your client only needs to understand this profile once and can be reused. Same goes with relations. As for navigation across services, in this case you have a ship that's living on one server, and it refers to a company that's living on a totally different server. So that means that you can have these clients that are not tied to one particular API. But they don't need to know that the API is spread out over a lot of different services. So it's a nice way of introducing, for example, microservices. And like I said, it facilitates API evolution. For example, let's say that you move certain endpoints from one system to another system. They can follow the same relation. Clients that follow the relation twice end up in a different place, but they don't really know that. They don't need to know that. They just follow the relation. And at GoAbout, for example, we relocated our authentication endpoint once, and we saw that half of our clients had implemented Hypermedia and were fine with that, and the other half had just hard-coded a couple of URLs and then crashed. So the second API evolution is even more interesting, is a semantic change. So suppose you had ship owners, but you introduce ownership history. Make ownership itself a domain term, and you are going to register not just who the current owner is, but who the historical owner was. Then you need to add relations to an ownership entity instead of the owner. And you can add a relation, because existing clients will just ignore that relation. And you can set a deprecation property on the old relation, signifying to clients that they need to start thinking about upgrading. There's a URL there, and you can show these URLs to a developer of a client. If you have a good Hypermedia client, they will show these URLs to the developers, for example in debug logs. And then know that you need to start upgrading without breaking backward compatibility immediately. It's interesting if you use, for example, OAuth, not just to log in users, but also authenticate clients. You can then log which clients are still using the old endpoints, and you can start to mail them and talk to them and say, well, what can we do to help you to migrate to the new endpoints? And you can very fluently migrate clients from old endpoints to new endpoints. So that's why you would want to use Hypermedia and what they are. Now let me show you how this is implemented, or how I implemented this in the Django-rest-framework. So the Django-rest-framework is a great framework. I think absolutely the best way of implementing REST APIs in Django. It is beautifully layered. It starts with models, just like regular Django, where you have the entities and business logic. Then it adds views, also just like regular Django. And these look a lot like what I just described as resources, because they define the API endpoints. Then you add serializers, which look a lot like the serializers from Django Shop, I think. Forms in the way of HTML. They define the representation structure. So they are basically a bit of a translation between the models and what the API representation show. And then there's the renderers, and they define what the syntax will be of the API endpoints. So that means that if you look at the terms that I just used for the Hypermedia API, you could say that for the media, how to implement the media type? Well, you use a renderer. In this case, I use a HAL renderer. How do you define resources? Well, you use the views that REST framework gives you. And actually, django-rest-framework has a nice concept of view sets and routers that make it very easy to implement basically a set of views at once. Then profiles are defined by the serializer. So every ship gets its serializer, a company has a serializer. They define the structure. And then you add relations, and relations, of course, because they link from endpoint to endpoint, you would like to have those defined by the views. Only I've not been able to do that, unfortunately. So at the moment they are defined in the serializer, alas. So in the project that I just gave the URL to, you will find that this, the HAL, the Hypermedia specific stuff, can all be added to a package. It's called drf-hal. Might extract that from this and make it a separate project. And that means that all the Hypermedia specific stuff is in a separate package, and all the part from the API, so the ships and the companies and the links, all of that stuff lives in its own package. And the implementation is here. So there's a question for you. I was wondering whether to show something about what this looks like in code. Would you be interested in that? Or do you think you, yeah? Okay. Resounding yes. This is what it looks like in code. So this is the HAL package I showed you. This is not really semantically, this is not really the interesting stuff, I think. It's interesting how you use this to implement the ship registry API. So let's go there. So you start with the models. And these really look just like plain Django models. A company has a name, a ship has a number, an international maritime number, name and an owner. And that's really the content of the API. This is the information that the API serves to its clients. So that was the model. Then you get the serializers. Those are really the meat of the API because, as I said, they both have the representation and the links, unfortunately, in them. The first is company serializer. So what you see is that just like model forms, they define which model they will represent. They have tweaks like which fields to show, how to serialize a whole list of them. In this case, it's a whole collection. They define their profile, and they define the view name that you want to link to if you want to link to a ship. So this is used, for example, this is a company, of course. So if a ship wants to link to a company, if a ship wants to link to its owner, you will link to this view, a view that's called company. And this is in URL-conf, you register URLs and you give URLs a name. This is the name that's in here. And then, of course, the interesting thing is the get links stuff, because that's the Hypermedia thing. So in this case, a company has a link to the the ships that are owned by the company. And again, you link to the name of a view in the URL conf. And it says that you have to know the primary key of the of the company. So this refers to in the same way that you link to views in normal Django, basically the same mechanism. So then there's a ship, works basically the same, and it's in this case it doesn't link to its owner, but it will embed its owner, like I said. So it doesn't have a get links, it has a get embedded. And if it has an owner, it will use the company serializer to place the whole the whole representation of the whole company there. So that's serializers, and then what's left basically is views. And views define the so the URI endpoint, and then which query sets are used to find the information that will be passed to the API. In this case, search ships is a bit of a difficult one, so let's start with company. It's very basic. It just says, okay, look, these are the companies that you can choose from. And django-rest-framework already does a lot of the handling. Okay, it knows that you will have a primary key. It will match that to the primary key of the company. It will show a 404 page. If it's not found, everything like that is all handled by django-rest-framework for you. So in the usual case, you can just say, okay, this is the query set, and this is the serializer. Go for it. Now maybe the search ships view is interesting, because this is a view that's not tied to a specific model. So what you see here is that this is uses a mixin that knows about models, but the search ship knows about models because it knows how to take ships, of course. But it uses a query parameter, Q, and it uses that to look at the names of the ships, to filter those, and then it will use the standard list method from django-rest-framework. So again, django-rest-framework has a standard way of just handing over whole lists of objects to the API. So the views are basically exactly like Django, just the glue between the models and the serializers. Anything interesting? The rest is basically exactly the same. Maybe final thing is to show the URLs. So we just saw a couple of view names, and those are defined as those view names that they refer to. So this is something interesting in Django and Django-rest-framework, that a lot of these layers start to refer to one another, which is something that I didn't really like. I like to keep those layers separated, but this is just how it works in Django, unfortunately. A lot of duplication here, company ships, company ships, company ships. You already get the feeling that there is some programming where that just be one company ships. Right? So let's see what that looks like. So again, this is the shape of the API, right? Now I'm going to show you a HAL browser, a browser for HAL APIs. The project is deployed on the internet at the moment. If you go here, then you arrive at this thing, which is a very rudimentary but useful tool for browsing HAL APIs. So you see at the top that this is the root URL for the whole API. And on the right bottom you see the raw JSON that we got back from the server. And now on the left-hand side is the interpretation in terms of HAL. and it's separated in 3 parts. First is the state, so the real data from the resource. Then you have a set of links, and then a set of embedded resources, if there are any. And so what you see here is that the API route gives us 2 links. One of them is to, if we know the maritime number of a ship, immediately look up the ship, and the other one is to search ships. So I can use the, of course, this would usually be done by a special API, but this is a browser. So I can now say, okay, I want to search, and let's search for some prof. So I now follow the URL, and I arrive at the search results, which is a collection of ships. So there's no properties in a collection. So there could be, for example, total count. If you do paging, stuff like that, then you can add properties here. But basically, the only thing that's interesting here is the embedded objects. So a whole collection will embed all the found ships. And so if we open up the first one, we see that this is the first ship that is found. It's called the Providence. It has an IMO number. And like I said, if we follow the self-link, we arrive at exactly the same ship, but as its own resource. So it was really, the whole thing was really embedded in the collection. Now you see that again, it has this thing also has an embedded resource, which is the ship owner. To follow this self-link, you will again get the same resource back, and the owner itself has a relation to a collection of ships, which is the number of ships, the total collection of ships that it owns. So if you follow this relation, you get another collection with ships, but this time it's a collection of ships that this company owned. And so you see that you look at this. This is exactly the way that the API is structured, and this is exactly the way that clients will use this ship registry. Do you have any questions about this? Because I want to, otherwise I'm going to move to documentation.
Is there any rule or a rule of thumb you use looking at the database to represent many-to-many relationships?
That's a good question. Many-to-many, yeah, it's usually the case that a many-to-many relationship will be a link from one resource to a collection, and it will be from the other side also to the same collection. There's not really many-to-many relationships because so this is the best analogous data store is something like a document store, like MongoDB or CouchDB or something like that, and those kind of databases also don't have many-to-many relations. Yeah, sure. I can also repeat the question.
I wanted just to understand, when you got several items, how do you choose putting them into the embedded or in the links?
So
and
yeah.
You can put both and let the client decide.
Yeah, so a good question. The question is whether, how does the server decide whether to link or embed something, right? So the question is a question of business logic. So a client will request this. Why does it request it? Can I know that? Is it a collection? Then you know they will want the items of that collection. Otherwise, you won't get a collection. In other APIs, you can also use client-server negotiation in the same way as you have language negotiation or compression negotiation. There's also ways of as a client saying, well, I don't want these things embedded, I do want those things embedded.
You said earlier that there is the possibility of using several servers and have the client not worry about it. Do you have any examples where that can be useful? Because that sounds like a very interesting approach.
Sure.
But it's kind of complicated to, I mean, you probably have duplicated data on 2 servers or things like that.
It's often the case that there will be some communication below sea level between the 2 servers. One very clear example is if you have a company, for example, that say you have a company that uses organizations from the trade registry. You can have the trade registry as a separate API with separate endpoints for the different companies. And you can refer to those companies from within, say, an inspection API or some other information. So they refer to the authoritative location of these companies. Maybe they have their own set of extra data for those companies, but they will be able to refer to the that registry of companies. That's a good example. One. One more question.
I would like to know if there is any lazy hole serializer, so you are able, for example, to automatically serialize your model, inspecting it, and looking for foreign keys or one-to-many relations, for example.
Yes. So there's also another project. It's called DRF Hull JSON. It's more in that direction. You do need to add some metadata to the serializers, but it's pretty good at in finding out the different relations. It's something I personally don't like because I think in an API you need to think about it's like a user interface for clients, right? And we all know what happens with company websites when every subdivision writes its own pages and every group within a subdivision writes its own pages. You get basically the organization structure as a website, which is never what you want as a visitor to that website. So the same thing can be a trap in Hypermedia APIs or in APIs in general, that you just present your underlying data model to the client without thinking the use case for the API for the client. So what I like about this idea of making links explicitly and manually is the fact that you put the client first, and then you start to get back to the backend model. One last question? Yeah, sure.
Hi, so I wondered if you could talk about what exactly the client is expected to know about the API in order to be a successful client, because as I understand, the promise of Hate OAS is that the client doesn't actually need to know the structure and can just follow links. But if the client knows nothing, then it's like a user clicking around aimlessly on a website without really understanding what's happening.
Yes, absolutely. And this is it's a good question because it's sort of like a fake promise that many Hypermedia proponents give out. So the client doesn't need to know anything, but it doesn't need to know things. It does need to know mainly 3 things, which is a root URL, relations, and profiles. So you need to know the root URL to start somewhere. You need to know the relations to be able to follow the API wiring and do anything useful with it. And you need to know the profiles to understand what kind of data you're getting back. So in this case, you need to know those profiles like ship and company. So you need to know a company. The property name in a company means it's the name of the company. the IMO property in a ship is the international maritime number of that ship, that sort of thing. You need to know that, so profiles. And you need to know relations, because you need to know what the ownership relation means. So you need to understand that if I want to know what the owner of a ship is, I need to follow this relation URI. So those are the elements that you need to know as a client. Okay. There will be, I want to move on to documentation. Because what I found is, so at GoAbout we developed an API, Hypermedia API for our planner. And what we found is that it's terribly difficult to maintain client documentation. So no one likes to write documentation. But the problem is that, like I said, you want to, if you want to have documentation kept up to date, you need to document it very near to the place that you implement endpoints. So in a classical, API, you have these. For example, you could say, okay, you have views, and we add PyDoc to those view functions, and we have a generator that takes these PyDocs and put those next to the endpoints and say, okay, this endpoint here this is the documentation to that endpoint. And because the documentation, those PyDoc strings are very close to the implementation of what the view really does, there's a high chance that these will be kept in sync with each other. But in the case of Hypermedia, you don't want to document the endpoints. You want to document the relations and the profiles. And those are already a bit farther away from the implementation of what these things actually do. Although you could describe the profiles at least on the serializer, so that would be a nice way of keeping those close together. But even if you do that, then profiles and relations are very, very small things to document. And what you get when you try to document just profiles and relations is that you basically create an index, like an index in a book. Very, very short snippets of documentation and not really a sense of how to use the API as a whole, because as you showed, you will walk through this web of resources to get your work done. So you need a couple of profiles and a couple of relations to get the job done. And that means that you have to jump back and from what does this relation mean, what does that profile mean. And we found that it becomes basically a very long list of very small pieces of documentation, which are very hard to understand. So then you, of course, add tutorials and examples, but then the problem becomes that these will not be kept up to date. And we've had clients call us to say, hey, well, there's no tram in your API. And we said, yes, there is a tram in our API. And they says, it's not in the documentation. No, of course, we forgot to add information about what trams look like. So, in short, the problem, let's see, work? Yes. So examples and tutorials get out of sync, and the reference documentation on these Hypermedia elements are much too fine-grained to get understandable information for a client developer. So how to go about fixing that? I talked to someone from blendle.com the other day, and they had a really great idea, which I stole and I'm going to present to you. It's the idea of using living documentation, both for testing requirements, for documenting by example, and for keeping this documentation up to date. And this is in the form of feature tests. So people who were here this morning, they also heard about feature tests from Peter, I think. And this is one of the feature tests that's in the current project. It says, well, given a certain company which owns a certain ship, and when you get the ship and you follow a specific relation, then you will get the owner. And the response is, that's in the real feature, there's a snippet of JSON there. And this is what's called a Gherkin language that it's written in. It's Cucumber that pioneered this whole idea. Now you write these things in text, and then you of course want to execute these, and so you have to implement the individual steps, and this is what behave and Django behaves gives you. So you implement these strings with variables in it, and you get little functions that implement one little step. You can view the source code. It's really very small pieces of Python, which really speak for themselves, very easy to implement. And now the interesting thing is, if you have this, you can generate documentation. One online tool that you can generate this is Relish. You can generate on Relish, or there's an open source application that generates nice HTML from these feature files. It's called FeatureBook. If you look at how this looks, then you get something like this. This is fortunately nope. Oh, no. No, it's working. It's working. It's working. And then a slash on an Italian keyboard. Where's the slash on the Italian keyboard? Ah, great. Thanks. Yeah, is it? Yeah, it's good. There it is. So this is a documentation that's generated from these feature tests, and it adds a little bit of text to glue the whole thing together. And you can see that it's really quite readable. This is a short overview of the API, a description of what the root resource is, and then you see this Gherkin test here. So you see when you go to a certain URL, then states is this, content type is that, and you see a representation. So this is documentation that a client developer can very easily use to create clients from, but it's also provably correct because these are tested. These things also act as tests when you build a project. Similarly, you see here a description, for example, for searching for ships. So you have a ship called Providence with an IMO number. When you get the root resource, you follow the search relation with a parameter, which is a Q parameter you fill in prof, like I did just in the help browser. And you then get something, you follow the item relation because it's an embedded, the collection has these items embedded. And then you take the first of those resources, and then this is the representation. This is the ship that you will then search for. And so in this way, the documentation is kept in sync with the implementation because it's always tested. Now I wanted to show you something about API evolution, but I really don't have time for that, unfortunately. But you can look at it by yourself, or we can talk about it later. Okay. So I've talked about Hypermedia, how those are implemented in django-rest-framework, and how to use Django behave in these feature documentations to give client developers nice documentation that's up to date. Thanks.